Hi, this is Adjunct Professor Fred Kennedy at Diablo Valley College in Pleasant Hill, California. Today I'm going to talk about shifting bits. Let's start off by talking about shift right. If we have a simple instruction like shift right AL1, that would be shifting the bits in the AL register to the right by 1. So how does this work? Well, the rightmost bit here goes into the carry flag. All the other bits get shifted one place to the right here. So this one is here, this 0 is here, this one goes here. And the important thing is that once this bit is shifted, we have an empty spot here on the left, which is filled in with zeros. So if we do this again, to another shift, the rightmost bit goes into the carry flag. All the other bits get shifted one place to the right. And on the left, we fill in with another 0. So after 2 right shifts, we've changed this to this. And a carry flag ends up with this 1. Now, if you're shifting a sign number right, you have a particular problem. You have to worry about the sign bit, the leftmost bit here. Because if it's a negative number, you got to maintain its negativity, which means you have to copy the sign bit. Shift arithmetic right, AL1. This works basically like the plain shift right. The rightmost bit goes in the carry flag. All the other bits get shifted to the right by 1. But instead of filling in with zeros on the left here, we have to copy the sign bit. So if it's a negative number and the sign bit's a 1, we copy that here to fill in the empty spot. And if we do another shift arithmetic right AL, once again, the rightmost bit goes in the carry flag. All the other bits get shifted to the right. And once again, we look at the sign the sign bit, and copy it. Since it's a 1, we fill in on the left with a 1. Now, if the leftmost bit's a 0, which means it's a positive number, then we fill in on the left with zeros. And of course, on the right, we do our ordinary shifting. The rightmost bit goes in the carry flag. All the other bits get shifted to the right with shift arithmetic right. And if we did the shift arithmetic right again with a positive number, then we just keep filling in with zeros to copy the sign bit. Now, of course, if we can shift right, we can shift left. It's the same idea. The leftmost bit goes in the carry flag. All the other bits get shifted to the left. And we fill in on the right with zeros to fill in the empty spot. So if we did this once again, leftmost bits get shifted to the carry flag. All the other bits get shifted to the left. Fill in on the right with a 0 to fill in the blank spot. But there's a possible problem shifting sign numbers left. If you have a sign change, then you have overflow. For example, the same number starts off with a 1. If this were a signed number, that would be a negative number. It has to stay negative. But with one left shift, this 0 gets shifted to the left. All of a sudden, the sign bit is a 0. That means we've changed a negative number to a positive number, which is overflow. It's an error condition. Of course, you can shift more than once. You could put an immediate value for the number of times you shift, like shift left EAX3. But sometimes you want to calculate the number of times you shift, and you have to put it somewhere. If you want to calculate the number of times you shift, the number of times you shift has to be in the CL register. It can't be in ECX or any other register. It has to be in CL. So shift right EBX CL. So if we did a move CL4 and then did a shift right EBX CL, that means that EBX was shift right 4 times.